So we're looking at Newton's third law, and you'll be able to easily identify Newton's third law question because there's two objects in Newton's third law. When we looked at the first law, you know, like the stone, throwing a stone, or we're thinking about a car slowing down, F equals ma, those sorts of things, we're only thinking about one object. But for Newton's third law, we're thinking about the interactions between two objects. And Newton's third law basically says that this is, and it's not a great definition, for every action, there is an equal and opposite reaction. And so this is the first object, is the action, and then the opposite reaction comes from the second object. Okay, so we can think about this as in pairs. And our example, our first example is with a hammer and a tent peg. And we're going to hit the tent peg with the hammer. And so this is my action. The action is the hit the tent peg with the hammer. And so there's a force applied, an action force if you like, by the hammer on the tent peg. Okay, it's in contact and it's hitting the tent peg. But the tent peg, it's not like there's no resistance to this. There is resistance to this force. And the force then is the reaction, is that the tent peg pushes back hammer, and it's also driven into the ground. Okay, so what we have then is a reaction force. So this is why it's a pair. We're thinking about what is the forces on the hammer. The hammer exerts on the tent peg, and then what the tent peg does back to the hammer. We've got some other examples in our booklet. We've got a basketball player dribbling a ball. So pushing down on the ball is the action, but there is resistance from the ball when you're pushing to accelerate the ball, and so that is the reaction of the ball. And you can see that it also occurs with the ground. The ball hits the ground, that's the action. And the reaction is that the ground pushes back on the ball and the ball will bounce back up. Objects on tables. Action is the weight force acting down on the table. And the reaction is the table pushing back up on the object. But in actual fact, what we've got, the action is Earth's gravitational pull is pulling on that object. And you have the action-reaction pair of the car towing the trailer. So the action is to pull the trailer from the car. The reaction is that there is resistance from the trailer, and so it pulls in the opposite direction. Does that make sense? That what we're looking at here are pairs of objects. One is doing something, and the other one is reacting to that. And it's reacting to it in the opposite direction. There's some interesting pictures, well, relatively interesting pictures on the bottom of page 61. It's like if you are standing on a skateboard and you try to just step off it. What happens? You step that way, the skateboard goes that way. Same thing happens in a boat. If you're in a boat like this person in this cartoon on the bottom of the page, you go to step out of the boat, canoe or whatever, it goes in the opposite direction. And we talked a little bit about rockets and thrust and how what we've got here is if you concentrate on where the exhaust is coming out of the rocket, we've got the push of gases out the end of the rocket in that direction means that we then have the thrust of the rocket itself in the opposite direction. Just like if you blow up a balloon and you don't tie off the end and you let it go. Okay, you've got the air coming out the open end of the balloon in that direction, and the balloon will travel in the opposite direction with the thrust of those gases coming out to the end of the balloon. Okay, so the important thing to remember here is that these are all Wesen pairs. The action is the thing that's done. The reaction is however the other member of the pair reacts to that, and they are always equal and opposite in direction. And that's all we need to say about this third law. Any questions?
Is there ever going to be like somewhere where this doesn't occur, or is this like a fundamental law?
It's a law. Yeah, it's a law. Newton's laws apply in our everyday lives, and with some modification by Einstein, they can even apply, in all cases. But these laws are laws. So you can have principles and theories and everything, but the highest ranking is a law.
What do you mean, Victoria?